Okay, so what if I told you that all of mathematics, I mean every single equation, every proof you've ever seen, could be built from just one simple idea? Not some crazy complex formula, but a thought so intuitive you probably use it without even realizing. Today, we're going to dive into a principle so powerful, some of the most brilliant minds in history thought it could be the single seed from which the entire tree of arithmetic grows.
So let's just start with that central question, right? Forget all the complicated stuff for a second. Could the whole vast, incredible structure of arithmetic really be built on top of a single, almost common sense thought? I mean, that is a breathtakingly ambitious idea, and it all kicks off with a very simple act.
And that act is counting. But, and this is the wild part, doing it without using any numbers at all. Now, I know that sounds kind of impossible, but it's the beautiful, simple core of the whole thing we're exploring today, an idea called Hume's principle.
So what Hume's principle does is it gives us this incredible way to know if two groups of things are equal without ever actually counting them. It says you don't need to know how many F's there are or how many G's there are to know for sure that they have the same number of items. All you gotta do is see if you can match them up perfectly one to one. Think about it like this. You're throwing a dinner party. You've got your guests, the F's, showing up. You've got your chairs, the G's, set up around the table. Now, do you have enough chairs? You don't have to go around counting everybody, and you don't have to count the chairs. You just say, hey everyone, grab a seat. If every single one of your guests sits down in the chair and there isn't a single empty chair left over, then voila, you know with absolute certainty that the number of guests is the same as the number of chairs. That perfect matching, that's what logicians call a one-to-one correspondence. So yeah, it's a really clever party trick. But here's where the idea goes from being a neat little trick to being absolutely monumental. A group of philosophers, originally led by the genius Gottlob Frege and then revived by modern thinkers like Crispin Wright and Bob Hale, saw this simple principle as the key to unlocking one of the biggest goals in all of philosophy.
You see, their grand ambition was a project called logicism. It was this attempt to prove that mathematics isn't some separate, mysterious world of truth that we just happen to discover. No, they argued it's actually just a very, very complicated branch of pure logic. And if they could pull that off, it would totally change our understanding of what knowledge even is.
The philosophers pushing for this today, who we call neo-Phregians, they make a really bold claim. They say that Hume's principle is so basic, so fundamental to our very concept of number, that we don't even have to prove it's true. We can just accept it by fiat, basically by declaration, because it implicitly defines what a number is. It's like the word bachelor. You don't need to prove a bachelor is an unmarried man. That's just what the word means.
And this is where it gets really incredible. This is the payoff. The great logician Gottlob Frege proved something so amazing it's now called Frege's theorem. He showed that if you just take Hume's principle and you add the powerful tools of a system called second-order logic, you can derive all the basic laws of arithmetic, addition, subtraction, the whole shebang, all of it, from that one simple idea about matching guests to chairs. I mean, it almost sounds too good to be true, doesn't it?
And, well, maybe it is. Because as beautiful and elegant as this whole picture is, it ran headfirst into some really serious, really famous philosophical problems that thinkers are still fighting about to this very day.
Okay, so the first major roadblock is something called the bad company problem. Think about it. If we can just declare Hume's principle as true just because it feels right, what's to stop us from doing that with other principles that look similar? The big trouble here is that it's super easy to cook up principles that look almost exactly like Hume's principle but lead to total logical chaos, to contradictions. So if Hume's principle is hanging out with this bad company, how can we be so sure it's the one good apple in a barrel of rotten ones? And that leads us to the second and maybe the most memorably named problem in all of philosophy, the Julius Caesar problem. Now, the question sounds totally absurd, I get it, but it points to a really deep philosophical hole in the argument. Hume's principle is great at telling us when the number of F's is equal to the number of G's, but it never actually tells us what a number itself is. It defines numbers by how they relate to each other, but not what makes them, well, numbers. How do we know for sure that the thing we call the number 2 isn't actually, Julius Caesar himself? Does the principle really carve out numbers as their own unique category of object? And finally, we have the knowledge dilemma. You see, for us to just be able to declare that Hume's principle is true, it has to be what philosophers call conservative. That means it can't suddenly prove new things about stuff we already understand. And there's a big debate about whether it really is conservative. But more to the point, as critics like Robert Truman argue, you just can't get something for nothing.
A stipulation, a declaration, can be used to define the meaning of a word, or it can be used to assert that a statement is true. But you can't do both at the same time and then claim you've magically created brand new knowledge about how the world works. So all of this brings us right to the heart of the debate today. It's this grand intellectual tug of war, and it remains one of the most exciting, still unsolved questions in the entire philosophy of mathematics. So let's just break down where the two sides are. On one side, you've got the neo-Phrygians. They're claiming Hume's principle is a straight-up truth of logic, and that it gives us a rock-solid foundation for all of arithmetic. They say it tells us what numbers are and that mathematical knowledge is really just logical knowledge. But for every single one of those claims, the critics are right there to push back. They say its logical status is anything but proven. The bad company problem makes that foundation look really shaky. Julius Caesar shows the definition is leaky. And at the end of the day, you can't just create knowledge out of thin air by declaring something is true.
So, in the end, this absolutely elegant quest to ground all of math in pure logic leaves us wondering about the very nature of truth itself. It's one of the most ambitious intellectual projects ever attempted. But whether that foundation it's built on is solid rock or just shifting sand, well, that's still very much up for debate. And it leaves us with a huge fundamental question. Is mathematics this perfect, timeless system that we discover out there in the universe? Or is it a brilliant human invention built on a foundation that just might not be as solid as we always thought?